Threads and processes can be easy to mix up because they both have similar sort of applications, right? So they both can take advantage of using multiple cores. So the way I like to think about it, say I have my program and it's going to take it's running and it's going to take some amount of time. But within my within my program, I have multiple tasks I'm doing, right? So this is task 1, this is task 2, this is task 3. Right now, my program is only using one core in my computer, but a lot of computers have multiple cores, and I can take advantage of this and say, okay, computer, how about one of your cores works on this task, another works on this task, and someone else does task 3. And so threads and processes both use that, and that can actually speed up your time. So instead of taking this huge amount of time, they can run concurrently, and it's going to take a lot faster because you're basically just dividing up the work. Okay, let's look at the structure of how they're different. So we have a process, and every process is going to have one thread to begin with. And if we want to create a new process, then we can use the fork function call, and this goes back to, having a parent and a child process. And then you can communicate between the two using pipes or using files. But they're both isolated from each other because they have different virtual memory space. So on the other hand, if we want to have multiple threads, so let's have in process 1, we are going to have another thread. And let's just call this thread 2. Now it's going to share the code, data, and files, so most of the same memory. The only difference is it's going to have different registers and stacks. And this means, remember, our stack contains our local variables, and then our global variables are going to be in the data. And so if both these threads are modifying a local variable, it's going to be different, but they can both modify the same global variable. So when would you want to use a thread versus a process? So the great thing about threads is they're sharing a lot of memory space. So they're pretty much sharing everything except for the stack, which means you can modify the same global variable, and so that's how you're going to communicate between multiple threads. And the problem with this is that you can have synchronization errors or issues. So say one thread is modifying a global variable, but because both threads are running at the same time, the second thread could modify it at the wrong time, and this could lead to having data corruption or calculating the wrong value for your global variable. So some ways to fix that and synchronize your threads is to use mutex locks. So that mutex stands for mutual exclusion, and then or semaphores. And because threads share a lot of memory, you're obviously going to use less memory than a process would. But another issue is that threads are going to be less robust. So what that means is if you have one thread happily executing whatever it wants to, if that crashes, well, your entire application is going to crash, and all the other threads in your entire process will crash. And something that's interesting is your Google Chrome. You know how there's multiple tabs? Well, each of those actually are different processes. They're not threads, they're different processes. This is very intentional because say you're on a website on one tab and like it crashes, like your computer's communicating to another server when it's like trying to get a web page. And sometimes that fails, like you'll get a 404 error or like you'll freeze, who knows what. Well, like if that happens on one of your tabs, you don't want like all of your other tabs to crash. You still want to use them, right? So that's why they are processes. But threads are also really nice because they are fast. And what that means is they're going to use less CPU. And there are a couple of reasons why they're faster. So creating a thread is actually faster than creating a new process because like a new process means that you need new virtual memory address space and like another like open file table. And then also context switching is much faster across threads instead of like across processes. And then also there is faster intercommunication. And so threads communicate using global variables, and that's going to be faster than how processes communicate. And remember, a process communicates with another process using pipes or files. So just kind of a quick overview of process. Yeah, they have separate memory space, so they're going to be isolated from each other. These are basically kind of the opposite. Better failover handling, that's just like if one process crashes, it's not going to affect your other process, or like if you have more. So it really depends on like the applications you want to use these for. Just remember about your synchronization problems with threads. That's going to be a bit trickier to code, but definitely not impossible.